Hi, everybody. It is school break week, so time to do a stream late at night. I guess it's not that late, it's 6:30. I have an iPhone 6 here that I thought made a good case, and I also have an iPhone 7 Plus that I might come back to for a second stream tonight, so we'll stay tuned for that. So what makes this a good stream? This one, I think I know what's wrong with it. This is a prior repair attempt here for data recovery. So the deal with this phone is that it fell in the ocean. So the note is says drop the phone in the ocean. That's it. And so we need to get the data off of this ocean phone, but it's already been somewhere else. So my least favorite category, prior repair attempt. And I've been working on this for a little bit, and I can see that there were some things done to it, but there were also some things that were missed. So this one is a good example of how you can learn how to use your eyes. That is absolutely your best tool for board repair, is to notice. Now, it's hard to know what is normal and what is not normal. So it's a bit of an art that you have to develop, learning to use your eyes to do a complete physical exam. So we're going to go through this one. And let's see where it is as we start right now. Let's see, I'm going to prompt it to boot here on the desk, and we're going to see what the deal is. All right, so I'm prompting it to boot with a battery. So this is a battery and a dock. And it looks like it's turning on, short stream, everything's solved. I'll say nothing's wrong here, ready to go. All right, we are still repairing these. Yes, of course. The iPhone 6, the water gets all over iPhone 6s all day long. Greetings from Portugal. Greetings, Portugal. All right, so it looks like it's going to boot up, and it does. And now we got to put in the passcode, accept trust, in order to get the pictures off, and it has no touch. Now, I already did rule number 1. You don't have a board problem until you know you don't have a parts problem, and that's not the case here. So this device has no touch. So why does it have no touch? Let's start by taking it under the microscope, and let's see what you guys can notice about why this doesn't have touch. When we think about what are the common causes of no touch on an iPhone 6, you think touch disease. Well, touch disease doesn't really happen after water damage. So let's go on a hunt and see if you guys can notice anything. What is normal and what is not normal under the microscope here on this guy? So let's start at, let's also kind of take stock of what might have been already done to this board, because with a prior repair attempt, it might be technician damage or some kind of misdiagnosis. So let's see. I don't see anything interesting up there. Over here, we are missing a capacitor. That's not that big of a deal. And we can see our first sort of hint of water damage. So only this little speck here tells us, yeah, this board actually got wet. Not the stickers. Anybody can get a sticker to turn red, but that's actual corrosion on the board. Now let's look especially at the touch connector, because probably we're going to have all of these touch lines. And let's see, was this especially heavy hit with water around touch? No, it really wasn't. So that is a drag, because with water damage, the problem is where the water went, or wherever somebody did a prior repair attempt. Here's the first thing that I want you to notice on this second connector here. We see this a lot. We see this exact picture that you're looking at. Let's make it as crisp and clear as we possibly can for you guys. I hear this a lot. Connector replacement. Nope. You got to learn how to use your eyes, and your eyes can look at that and say, that doesn't make sense that we would have perfectly nice looking gold pins on the top and bottom and then burnt in the middle. No. And it can't be just missing out of the middle. So what is this? This is going to be some kind of dirt. And this dirt looks like sort of leftover thermal paste. And it is dirt, so we can just wipe that away if we were so inclined. So there we go. All right, that's part of learning to see what's normal, what's not normal. And we can see along here, all of this is normal. This is just thermal paste from probably ultrasonic cleaning, probably from brushing after ultrasonic cleaning. This thermal paste should, or at one time, lived here on top of the CPU. Okay, so let's go back. All right, what's going on here? We have some corrosion away of this test point, which is for backlight, and we're missing a component here. And then we can see that somebody has intentionally taken off the home button connector. So we'll just sort of note, because we don't care about any of that. All we care about is what in here has to do with touch. And then down here in the front camera connector, we really don't care about any of that. And then touch system. How does touch work? Touch ends up being delivered out here to, what? Oh. Touch ends up being delivered out here to the connector, all of the power and data for touch, and then it goes into the screen. So we're looking for problems here at the connector, and then we can follow it back. Power for touch ends up being generated by this guy, Chestnut. Now as we look around Chestnut, we can say, does Chestnut, it looks pretty, I don't know, not factory clean, but is that really a big deal or not? And I think that we just have more of this thermal paste from the top of the CPU is just kind of like everywhere. Now that by itself isn't conductive, and that's not really going to get us into trouble. It's just kind of messy. So if we have to ask, did water actually go under Chestnut? I really don't think so, because I don't see any of that oxidation around any of that stuff. All right, so then let's kind of move along and see what else. None of this really has any relationship to touch as we look around. Let's go down here, and I don't really think that water, despite this being dropped in the ocean, I don't think that there was really water down here at all. No sign of water on this bottom part of the board. This, I'm not sure what's up with this like weird looking screw hole thing there. I don't know what's up with that. But that's just something to jump out. Hi Jessa, Ricardo from LA. What's up, Ricardo from LA? Touch disease. All right. Let's flip back over here, and this doesn't look like there's very much water. And then what's going on here? All right, we got something weird going on here. But let's think. Does anything have to do with touch down here? No, this is a charging chip, Tigris. And this is the MOSFET, which looks like a big blob with a wire in it. Now, it's easy to go like, oh, that's terrible. Get rid of it. It's not supposed to be like that. Yeah, but, you know, this is the MOSFET, which experimentally we know you can take off and place a wire there. And we know that people do that when they're troubleshooting some kind of a main power rail short. So that doesn't have anything to do with touch, and we're going to leave that alone. That's not that doesn't have anything to do with our problem, even though it is unusual. TriStar, nobody's ever changed TriStar, which is great because TriStar doesn't have anything to do with touch. Aha, somebody has been here before us and taken off a capacitor next to the NAND. Not important for touch. So we're going to notice it, but we don't care. We're going to move on. All right, along in here, I can see a little bit more of what is probably bona fide water damage. This looks to me like corrosion around the crystal, and just kind of in that little corner though. Not really under the power management chip. And now here we get to the actual touch IC. So let's kind of look around here at the touch area. Audio IC looks okay. And now up here we can see, I don't know, this looks a little bit dirty, messy, fluxy. Not sure why. But I don't see a ton of the like corroded edges of the capacitors. This one looks like it might have gotten a little bit, no, I'm going to take that back. I don't think so. And I see a little bit of green, a little bit of water was here in the corner, but I don't see clear evidence that water actually went under the touch IC here. And then we can see over here is Cumulus, and let's see, Cumulus looks okay. So what do you guys think? Let's hear from chat. That is our visual exam of this board. Why would touch not be working? We know how touch is processed. Touch has power generated from Chestnut, which kind of looks okay. It goes out to the connector, which kind of looks great. And then all of these individual data lines are going to feed back to Touch IC number 1, Mason, which is going to coordinate with Touch IC number 2, Cumulus. These guys are going to talk to each other. And then we have processing of touch done by CPU, which looks great as well. So what are we missing here? What do you guys think is going on with touch in this device? Let's see what chat has to say about that. Hello from Indiana. Touch disease. If Mason has big readings, it may cause touch problems. Yeah, Mason could cause touch problems. Cumulus could cause touch problems. Chestnut could cause touch problems. Anything in between those chips and the connector could cause touch problems. But what is causing touch problems in this device? What do we do next? How do we proceed? All right, somebody asking about CPU. Hi from the UK. From what I can see, touch isn't working. Yes. So why is touch not working? The sooty looking stuff is all thermal paste. This is definitely a rehot CPU. Okay, so what do you guys think? Give me an idea. We got to know what to do. I know that chat is on a little bit of a delay, so we'll give you a second. What do we do next? You know, water, the problem is where the water goes, but I really don't see a ton of water on this board, even though it was dropped in the ocean. There is water damage, but it's very on the corners, on the periphery. It doesn't really seem like it's likely to be under these touch ICs or under Chestnut. Is the test display good? Yes, that's rule number 1. You don't have a board problem until you know you don't have a parts problem. So we're using known good screen that just recently was proofed on another iPhone 6. So touch is definitely working on that screen, but that's a good idea. All right, Fokker says measure FPC on diode. So it's not a terrible idea to say, let's measure diode mode in the connector to see if any of these beautiful looking lines actually come up as short or open. Now for touch, none of them, for the majority of this connector, these lines are just going to go straight under Mason. So it could tell us if there was corrosion under Mason, but it would be really tough because if you take a line A and a line B that both have this general same resistance and you merge them together through corrosion under Chestnut, that's not really going to change your diode mode reading because it doesn't make the line open. It doesn't make the line short to ground. So if you've got a line that's supposed to measure 600 and another one 600 and you marry them together, it's still going to be about 600. So it's probably not going to help us in this situation, which is the point of the video. So let's see, does anybody else have an idea before we just kind of move on here? I'd first check Chestnut voltages. Now that's a pretty good idea because Chestnut is either working or not. And Chestnut's job is to generate those touch voltages that go out to power the touch chips. And so we could figure out where to measure the actual voltage to ask, are the touch ICs actually getting power from Chestnut? So I like that idea. That would be good use of the multimeter. So I like that one. ZXW time. When in doubt, probe it out. Screw damage. Screw damage is a great idea because this is the use your eyes stream. So let's see, is there any kind of screw damage, especially because this is prior repair attempt. So let's stare down those screw holes. Looks good on that one. This one is filled with a bunch of schmutz, but there's no actual damage to the board. Same as that one. Okay, so no screw damage that we can see. And now I'm going to tell you why on this board I'm not going to bother doing diode mode in the connector for touch. I'm also not going to bother, at least not right now, I'm not going to bother to change Chestnut, and I'm not going to bother to measure Chestnut either. And I'm not going to bother to lift up and peek under Mason or Cumulus, which is really almost all of the touch system. And I'm also not going to lift up the CPU. And here's why. Because of my eyes. So when I was looking on this board earlier, one of the big strategies that just makes everything crystal clear is to get in the habit of working on an angle. So when you look straight down, everything shines light back up at you. It looks very even. It always looks really good. But you can get a completely different picture. Things will jump out at you when you look on an angle. So let's see if you guys can notice anything when we put the board on an angle like this and we start looking around. So on an angle, looking around, do you see anything that jumps out at you? Do you? Hopefully you do. Hopefully you see that there is a resistor back there that is tombstoning up off the board. Look at that. Now you always want to look when you're looking for water damage. Water damage often goes under these little brackets. And the only way to see that is to kind of put it on an angle and peek. And when I did that, I could see that this is, I don't know how this came to be like this, but since I don't see any water around, that's probably some kind of a poke. I'm not sure why anybody would be poking around there, but that's probably just, maybe somebody held the board like that or something. Somebody knocked that dude off on one side, and he's still there. See it? We can kind of touch it and move it. Now, does this guy have anything to do with touch? And also, while I'm looking here, my eyes are really drawn to this guy. This guy looks like a resistor. Look at that, but it doesn't look as nice and clean and clear as the neighbor. This guy looks pretty corroded, and the chance that he's making good contact on both sides is pretty low. But do any of these have anything to do with touch or not? Because they're, way over here in the corner of the board. Now is the time to look these guys up to find out. Because if they do have something to do with touch, then we have a really good lead. Fix the problem. If they don't, then maybe it's more open-ended, but I wanted you guys to see that. So let's go on a hunt. Let's go to, let's see, do I even have ZXW working today? Yes, this is iPhone 6, and we are going to look up, let's kind of make it more clear. ZXW, let's put the board the same way as ZXW. And let's peek on an angle, and we can see the guys that we want to look up. We've got sort of 3 caps in a row, and then a little cap, and then here's our resistor. And then separately, we've got 3 resistors, 4, and the number 5 one that looks kind of corroded. So that's what we want to look up on ZXW. So let's go over there and give it a hunt. All right, so here's 1, 2, 3, little cap. And then this is the tombstone resistor, R2403. And then looking over 1, 2, 3, 4, 5 in a row, this is the corroded looking one here, which is a Stockholm RF clock line. Stockholm, Apple Pay, that doesn't have anything to do with touch. But what about this guy? So let's look back and ask about R2403. So I see the name, Touch. Touch what? Touch to AP, SPI, MISO R. What the heck is that? R2403. Let's get a little bit more detail from the actual schematic. So R2403 on the iPhone 6. R2403. Let's look it up. R2403, which we know for sure with a resistor on that line, tombstone like that, this is going to be an open line. So here we are at Touch, and we've got Mason, the big black Touch IC, Cumulus, the little guy, and we can see here at Cumulus, we've got this line here, which is called Touch to AP. AP means application processor, CPU. Touch to CPU, Touch to AP, aka CPU. SPI, MISO. Master in, slave out. This is a data line. And this is a 10 ohm resistor that is going to connect this data line between the CPU and this Touch IC Cumulus. Now, if we look at the chip overall, we can kind of guess what does it do. Probably power in up at the top, and then all of these really similar lines over here, Sage to Cumulus in, these guys are going to be a connection, a talking point between Mason and Cumulus. And then we've got our control and regulation over here in this section. So things like enables and resets and interrupts and clocks tend to be really important to the overall function of the chip. And if you don't have that, then it's real easy to take out that function entirely, which is what we're seeing, no touch at all. So what do we need to do? Well, we're going to put this guy back on the board to close touch to AP SPI MISO and see what happens. And this guy is another sort of example of experience. I have seen that guy get corroded off the board from water damage before. In fact, I've spent a long time, days, hours, troubleshooting all water damage around Mason and Cumulus. This case, though, is just really, really crystal clear because there's not a ton of water on this board. So it's just unlikely for water damage to be affecting these chips, touch chips. They're close, but they just don't look like they really got wet. So I'm going to wiggle off this bracket to get some clearance. And this one, we're going to see whether or not this guy looks like he's in good enough condition to stick back down there, or if we need to actually go hunt down another one. We can't just jump it because it's a 10 ohm resistor and we want it to have that same resistance. So what I'm going to do now is make puffy pillows so that we can get this guy back down there. Your videos just make my damn day, says Brad. High five, Brad. Thanks for watching. All right, let's see what we can do here. All right, we are going to let's make it so that you guys can see. Let's try to focus on making it so everybody can see. There's our dude. And now he's never going to lay down until he has nice, shiny, puffy pillows. All right, so we're going to make him some nice, puffy pillows. All right, that looks great. Oh, do you guys hear the lovely sounds of my roommate, the dog groomer? Great! All right, I'm going to make this guy really stick on there nice and perfect with a little bit of hot air, even though he's on there okay right now. But let's just kind of straighten it up a little bit. Shine it up with our leaded solder. There he goes. A little bit of surface tension to poke him and move him right back into place. Great. Now let's see, is that all that it took? Is that the only thing that was really standing in the way of this board and recovery from its ocean damage? Let's go to the hand cam and let's find out. Let's find out. Alrighty. You can jump it with a really long jumper wire. That is true. We did another stream. I think it'd be fun to do like a highlights of iPad rehab channel. So if you've been with us for a long time and you remember like a funny moment or something, I know we have these, tons and tons of these super long ancient live streams that never get edited, but it would be fun to go fish them out. I can remember we did one stream, Mark and I did one on one of these iPhone 6 reset short to ground within the CPU where we had to create a jumper. So we had to create a resistor that we didn't have. So we ended up using Christie's bobbin wire that she sells on iPad Rehab Supply. That is our jumper wire. So we measured in that one bobbin, it was 100 ohm resistor. Just like this, you could measure from one side to the other. You would have a certain amount of resistance. So we started winding up these sort of like custom resistors. Super fun. It worked in the end. All right, so now let's see whether or not this has touch. If not, then the stream will be completely the wrong title and it'll need a new title as we'll have to go on and continue to troubleshoot. So if not this, then my next step would be to say, all right, I still wouldn't measure in the connector because I just don't think it's going to tell me anything. But I liked Rodrigo's idea of measuring chestnut voltages. Hey, unnecessary because touch works. All right, there we go. But I would measure chestnut voltages in the iBridge. And then if chestnut voltages were present, then I would probably go for Mason because there could be corrosion under there. We see it as kind of a hot spot for corrosion. That would be my next guess. But there you go. Touch is working, and we have trust this computer. Or is it still plugged in? Uh-oh. I'm supposed to be answering the phone. All right. I'm always wary of letting you guys see their passcode, so let's kind of take that off. There we go. All right. And, whoops, came disconnected. So this one I don't think has a passcode. Let me find that out. But we're going to get it recovered. And that one, I think, was a good example of how to use experience, because that guy has gone bad before, and knowing that your eyes are really a greater tool than the multimeter. All right. Let's do another one. I do actually have another one here that seemed like it would be fun. All right, so there we go. Touch is working, and we are going to have a path to data. All right, sweet. All right, I'm going to move this over to ready to recover. Touch is working, and they're going to be able to get their pictures back. And I think I'm going to get that going, and then I might come back here and start a second stream because I have a little bit of extra time on a really cool 7 Plus that's got all of the twin toddler. That's really always pulls at my heartstrings as a mother of twins, that got to get the twin toddler pictures out of that 7 Plus that looks really, really corroded. So come back and see us in, I don't know, 20 minutes or so, and we'll see if we can knock that one out today too. So thanks for watching, and don't forget, use your eyes. Use your eyes. Your eyes are your best tool.